So we left off calculating the derivative of this function, and we found two critical values by saying that if the derivative fails to exist for whatever reason, that's a critical value of the original function. But both of those were not helpful to us. Based on the model for this situation, I don't want to put my plant inside the same physical space that the lamp is occupying. In fact, I don't even know how that would work. And neither do I want to put my plant on the windowsill, because I get more sunlight the closer I am to the windowsill. So I'm looking for a minimum which would put my plant somewhere in between the window and the lamp. So my other possibility for finding a critical value is I want to know, where does this derivative equal 0? Now, I'm going to set up my equation here. I am solving for what value or values of x will make my derivative equal to 0. And I'm going to do this using some algebra. It looks a little bit hairy right now because I've got the difference of two fractions equal to 0. So what I'm going to do is I'm going to do the most obvious things first, and then work my way down to just having a simple equation. Since I have the difference of two fractions equal to 0, this will be easier if I just have one fraction equal to another. So 2 divided by x cubed must be equal to 6 divided by the quantity 10 minus x, all cubed. Okay. Now, I'd have an easier time with polynomials than I would with fractions. So the next thing I'm going to do to simplify is I'm going to cross multiply. I'm going to multiply both sides of the fraction by x cubed. And I'm also going to multiply both sides by the quantity 10 minus x, all cubed. So that way I do get these nice polynomials instead. So 2 times the quantity 10 minus x cubed equals 6x cubed. Well, I could multiply everything out. And I could subtract that x cubed and see where things fall. That sounds really hard, though. I want to see if there's an easier way to do this. Well, I notice that both sides of this equation have a coefficient. So here a 2, over there a 6. And then both sides of this equation are something to the third power. So I'm going to simplify that coefficient. I'll divide both sides by 2. On the left, I'll have 10 minus x cubed. On the right, I'll have 3 times x cubed. Okay, well now what am I going to do? If I've got both sides with a cube root, with a cube in them, I'll take a cube root. So taking the cube root of the left-hand side gives me just 10 minus x. Since cube roots, that's an odd numbered root. Cube roots are defined for all numbers. I don't have to worry about plus or minus over here. It'll always exist, and there's a single answer that could have. On the right-hand side, if I'm taking the cube root of all of this, well, to begin with, I would have the cube root of 3 times x cubed, but that's the same as the cube root of 3 times the cube root of x cubed, but the cube root of x cubed is just x. So on the left-hand side, once again, I've got 10 minus x. On the right-hand side, I've got a coefficient, the cube root of 3, that's just a real number, times x. All right, I'm getting very close now. I've got number minus x on the left-hand side. I've got number times x on the right-hand side. So how am I going to do this? I'll move all the x's to one spot. So I'll add an x to both sides and say I've got 10 equals, well, what have I got here? I've got the cube root of 3 times an x, and then I'm adding one more x. So let's call this a coefficient of cube root of 3 plus 1 times x. So just gathering those coefficients. And my solution is that x should be equal to 10 divided by this number. The denominator is going to be the cube root of 3 plus 1.